Hey guys, in this video is lesson 8.4 and I'm going to go over some practice problems for today. In these practice problems, there are 5 questions, but they're all examples. So remember, like before, these are the examples, and then on the PDF, there are separate questions. So just make sure you are aware of that. So our lesson target for today in this video is to review and apply formulas for area of a sector and arc length of a circle. So I'm going to first start off by going over some of the formulas. So area of the sector is, again, a portion of the circle. So we're not talking about the whole thing. So just make sure you remember that it involves a fraction in this problem. So we are looking for a fraction of our circle, but we know that the area of our circle is pi r squared. And this is going to be similar when we are also looking at arc length, because arc length represents a piece like a crust in the pizza itself, so just one crust. So we're looking for a portion, which is represented by this fraction, of the crust of the circle, and usually we use the circumference formula to find that. So there are 2 examples here. My first example is I have a radius of 5 and an angle of 80 degrees. So let me just draw this out so that you guys have an idea of what that looks like. So let's pretend this is like 80 degrees and then our radius here is 5. So if I want to just input these values into the formula, what I would get is 80 over 360 times the circle, which is pi 5 squared. And then I'm going to solve for this. So later I'll show you guys how to solve, but this is how I would plug this into the formula. And then let me replicate this image. And then if I were to plug that into the formula, I would get something like so. Okay. And then again, just solve for it, and then you should come up with the final answer. So this is just a generalization of how you plug things in. All right, so let's do example number 1. So if a circle has a radius of 8 centimeters, what is the length of the arc with a central angle of 50 degrees? So I have to go back to the formula just to make sure I know what my equation is. But in general, length of the arc, or you can call it arc length, is going to equal to theta over 360 times 2 pi r. So make sure you distinguish between the 2 formulas and know if it's 2 pi r or pi r squared. So if I were to draw this into my picture, so my radius is 8, my theta is going to be 50. And notice how I labeled it so that when I get to the formula itself, it's just an easy substitution. Okay, so that's how it should look like. And then I'm going to start solving. So in this problem, what I could do is actually simplify what I have in the parentheses first. So that's technically going to look something like this, because 8 times 2 is 16. And then notice that when I do this, I can just put this over 1 and then just calculate across. So 50 times 16 is going to get me 800 pi. And then I'm going to divide the rest by 360. So my final answer in terms of my arc length is going to be 2.22 pi, and then just centimeters, just because I'm dealing with arc length, okay? So this is the length of this piece right here. Okay, that's example 1. Example 2. So now example 2 says, if a circle has a diameter of 18 inches, what is the area of the sector with the central angle of 120? So I'm looking at a diameter. So that means it goes from one side to the other. However, I'm only looking for the piece that is 120 degrees. So I'm just going to add another line in. And I'm going to say theta equals 120. So the piece that I'm looking for is this piece right here, so you guys don't get confused because there's a lot of lines going on right now. But notice that they gave me my diameter. So they gave me this whole entire piece of 18, which means that I know my radius, because usually I just need a radius, is going to be half of that, which is 9. So area of a sector, the formula here is going to be theta over 360 times pi r squared. Okay, so now I have all my information. I have 120 over 360. and then plugging in 9 squared. And then if I were to simplify the inside, I should get 81 pi. And then put this over 1 so that you can just calculate through. I'll just keep going down. So if I were to calculate this through, I get 9,720 pi over 360. And then divide, and then my final answer, I'm going to put it here because another room is 27 pi inches squared. I should box it up as well. Right, so that's my final answer for the area of just that one piece right there. All right, example number 3. If the measure of the angle is 90 degrees and has an area of 25 pi meters squared, what is the measure of the radius? So this problem is a little confusing just because they did not give us a radius. They already told us what the area is. So what are they really trying to ask me for? Okay, so I'm just gonna draw out the image just so that you guys have a better idea. So this is 90 degrees, so I know that this is a right angle right here. So maybe I'll just do some labeling. And then radius, I don't know what it is. They want me to find it. But in general, I know this whole entire area is actually equal to 25 pi meters squared. Okay. Okay, so if I want to figure out what my radius is, I already actually have a formula that I could use and manipulate so that I can find my radius. So notice again that the area of a sector in general is going to equal to this equation right here. Okay, so why can't I just use this equation and just move things around to find my radius, which is what I'm going to do right now. So area of a sector, I know what it is because they told me right here, is 25 pi, okay? My theta, which I've also already labeled, is 90 over 360, and then plugging in nothing else because there's nothing else to plug in. Okay, so now that I have that, my goal here is to get my radius all alone because that's what I'm looking for. So the first thing that you want to do is always to move everything that is in the way onto the other side. So the first thing I'm going to focus on is I'm going to focus on the pi because the pi is really easy to get rid of. What I could do is just divide pi out on both sides like so. So this gets canceled, okay? After I get rid of that, the second thing I'm going to do is get rid of the fraction. So if I want to get rid of the fraction, something I can do is actually to multiply this by its reciprocal. So if I multiply this by its reciprocal, notice what happens. This gets canceled out with that, and then the 90 gets canceled out with the 90. So that's taken care of. And if I were to do something on one side, the other side, I'm going to do exactly the same thing. And I'm getting really close to what I want. So from here, I'm going to multiply the top, and then the bottom, technically it's 25 over 1, so I'm going to multiply the bottom together. So if I multiply 360 by 25, I end up getting 9,000. So 9,000 over 90 is going to equal to r squared because that's the thing that I have left over on the other side. And then I'm going to divide my 9,000 by 90, which is going to give me 100, which is perfect because notice the last step here is to square root both sides. And then notice that when you square root, you do get positive and negative 10, but here because we're talking about length, we know length should be positive. Therefore, we finally know that our radius is actually 10. Okay, and then if I were to find my diameter, just because I'm extra, I just got to double 10 to find 20. So that's how you do that one. Okay, and then similarly, we're going to do an example number 4. It says if the measure of the angle is 180 degrees and has an arc length of 70 pi, what is the measure of the diameter? So what I know here is that I have a theta to be 180 degrees. And notice that's half of our circle. We also have a diameter that we're looking for, so we have no idea what the diameter is. But what helps is that we find the radius and then it gives us our diameter. So we're kind of doing a similar problem. And the arc length, which is this length right here, is equal to, they told me 70 pi centimeters. Okay, so we're focusing in on arc length. We do have a formula for arc length, which is great. And then it's theta over 360 times 2 pi r. Okay, so substitute everything that you possibly can. The arc length is 70 pi itself. Theta we know is 180. And then 2 pi, my radius is missing. So first thing that you probably want to do is just divide out the most easiest things that you can divide out. So I would divide out the 2 pi. So earlier I told you how to divide the pi, but 2's here too, so might as well just take that out while I'm at it. So I'm going to divide 2 pi first. And then if I were to do that, I do get 70 divided by 2 is 35. And I still have something like this. And then I still have my r. So notice how close I'm getting, exactly what I want, because I just want r by itself. And then therefore, our last step is to multiply by its reciprocal of our fraction. So that can cancel and that can cancel. And then multiply that on the same side on the other side. And then I'm going to multiply that out. So if I were to multiply the top portion out, I get 1,000 or 12,600 and divide that by 180 to give me my R value. And if I were to actually divide that by 180, I should get 70. So my radius is going to be 70, but I'm not looking for radius. I'm actually looking for diameter, and you know you can double it to get you the diameter. So pretty easy. You can do it in your head. So that's what our diameter is. Okay, and then our last problem. So hopefully today was not too bad. It says a certain car windshield wiper clears a portion of the windshield in the shape of a sector as shaded in the diagram at right. If the wiper pivots at 120 degrees during each swing, what is the area of the windshield that is wiped in each swing? So they are looking for area of a sector. So we know that we have to focus in on this equation. So the equation that we are focusing in on is theta over 360 times pi r squared. Okay, so notice that in this image, we don't have the whole entire sector. Notice that a piece of the sector is actually not included. So how are we going to do something like this? So what you should notice that is this is actually a part of two circles. So we have one big circle on the outside here, and then one little circle on the inside here. So what we can do is, if we were to figure out what one portion is and then subtract it from the other portion, that will give us our final answer. So we're going to figure out two things. So the first thing we're going to figure out is the area of a sector of our larger circle. And then we're going to subtract that from the area of a sector from our small circle, okay? Okay, so notice that both of those have the same measure. So both of those are actually 120 degrees. So I'm gonna plug that into my formula. So let me just do one piece at a time so that you guys can see both. Okay, and then I have pi and then r and then squared, and I have pi, r, and then squared. So we got to figure out what our r value. So our r value for our first large sector is actually this whole entire thing. So notice that it's a 20 and an 8. So in total, I have 28 as that piece. But for the other piece, what we have is not both of them together. We just have this little section right here, which you should know is 8 on both sides. Okay, so this side is 8. So if I were to multiply everything out, so the method I have used before is I multiplied 28 squared, and then I multiplied that by 120. So I get a total of 94,080 pi. I'm going to divide the whole thing by 360. And then I'm going to subtract that by doing 8 squared, which is 64. So 64 times 120 is 7,680 pi over 360. And then individually, these, if I were to continue to divide it out, is 261.33 pi. And I'm going to subtract that from 21.33 pi. And then therefore, my final answer, if I were to finish off is the area of that just windshield wiping piece is going to equal to 240 pi, and which unit am I in? I am in centimeters, and then squared, okay? So these are the 5 problems, and then hopefully you guys are able to get through it. Remember, the PDF is different. So I hope you guys have a great day, and make sure that you submit your attendance for today as well, which is in the Google form format. Bye, guys.